Hi everyone. In today's video, we're going to talk about the static keyword within the Java programming language. So if you can guess, if you've seen a few of the videos so far on keywords, there are probably going to be at least 3 use cases for this keyword. And I'm not going to disappoint, there are actually 5 that I'm going to cover this time. The normal 3 that we cover are for fields, methods, and classes. And then the 2 additional ones we're going to cover today are going to be static initializer blocks and import static. The common theme here we're going to talk about is that the static keyword refers to something that belongs to a class rather than an instance of a class. You'll see that theme kind of recurring with various uses of the static keyword as we go into things such as when you make a static field or a static nested class, or even import static where you're importing some static information from a different class. So without further ado, let's get into some code with IntelliJ. We'll go ahead and call this project static demo create. And we'll go ahead and open up the main class. And I'm going to create a new class called static demo by right-clicking new Java class. And now normally what I would do is I would create an instance of this class within my main class within this main method here. But this time I don't have to do that because the keyword static implies belonging to a class rather than an instance. So really I'm not going to have to worry about instances very much in this video. Now, the first thing you're going to notice is I actually am already using the static keyword once in here, and that is with the main method right here. I'm not going to go into a lot of details on why the main method is static, but I'll give a really brief introduction here. Basically, what happens is when the JVM boots up the generated bytecode after you've compiled your Java and you're running it on your target machine, it figures out where the main method is. And what it does is now it doesn't have to create an instance of your class. All it has to do is call the main method directly from within the JVM. And boom, your code starts. You're not going to be able to have references like you normally would when you have an instance around for things like this and super. Instead, you're going to have to deal with everything in a static context. So what that means in the case of a main class, especially if you're newer to Java, the only code you're going to be able to put in here if you want to call it directly is static methods. So let's say that I create public void method 1 with nothing in here. It's not going to return anything. You might find if you try to call method 1 within here, you get an error and it says non-static method 1 cannot be referenced from a static context. So let's break down a little bit what that means. So non-static method, which is method 1 because there's no static keyword in here, that makes sense. I can't reference that within a static context. So the static context means that I'm within a method which is declared static, and you can't access non-static methods within a static method directly. The way in which you would do this is you would need to create an instance of your main class, and then you would do m.method1, and that's how you get rid of the error. Okay, so while we're talking about static methods, I'll go ahead and create a static method in my static demo class just so we can see an example of that. So static demo, public static do something. And it needs to have a return type. Doing something. Now you might think because in the previous example we had to create an instance, we would need to create an instance of static demo here as well, but we don't this time. And the reason for that is because static demo has a static method called do something. But we also can't just do this. And the reason we can't is because my main class doesn't know what do something is directly. All that it knows is that there's a static demo class and that there's a do something method within the class. So you can see that IntelliJ is trying to ask if this is what I want to do. And yes, it is. So when I do that, now the code compiles. I'll run this just to demonstrate it's working. And as expected, we were able to call do something from within the static context of our main method. Very good. Now, just because you want to call a static method doesn't mean you always have to call it within a static context. It's just when you enter the static context, now you can only call static methods or use static fields. So let's go ahead and demonstrate that. I'll create an instance of main, and I'll create a method called method1, and I'll do main.method1. So now I'm in here, and now you'll see I can do the same thing there. I'll get rid of this. In method1, and we'll run this. And as you can see, when we were in a non-static context, we were able to call a static method. The thing you gotta be careful about is as soon as you enter a static context, if you want to deal with an instance, you have to now create that instance, because you no longer have any instance context within your static context. So I don't think I explained that super well, so I'll demonstrate here with some code. So I'm within some static context here. What I can do now is now I can create a main instance, and well, here's the problem. If I call method1, we're gonna see some funny business going on. Let's go ahead and run this. And our program blew up. Okay, so what happened? So if we look here at the stack trace, I'm seeing a lot of repetitive static demo main.java lines 6 and 9. This is a really long stack trace. Okay, now we're here. And we get the dreaded Stack Overflow error. For those of you who are programmers and like using Stack Overflow, that name isn't just for show. There are legitimate things called Stack Overflows, and what this is right here is we had some infinite callbacks between methods and instances, and what we did is the depth of method calls that we made was too deep for the JVM to handle. So a little bit of a fun example of we can still call static methods within non-static contexts, or when you're within a static context, you can still create an instance. What you can't do is you can't access instance information within the static context that you otherwise would within an instance context. All right, so the next thing I want to cover is a little bit related to methods, and that's going to be import static. So I'll go ahead and clean this up a little bit here. All right, so for the import static example, I'm actually going to use the math class within the JDK, and I'll go into why here in just a second. So I'll go ahead and have result equals math.pow. And I think the first one is the base. So let's go ahead and we'll do 5, because we're talking about doubles, to the third power, which should be 125, I believe. Go ahead and print this out. All right, so this looks good as expected. 5 to the third is 125. Let's say that I didn't want to have to call out math dot every time. Let's say that I have a class where I'm doing a whole bunch of mathematical operations and I want to just say pow, or I just want to say arctangent or cosine or whatever various trigonometric functions I'm using in my code, and I don't want to have to precede everything with math dot. There's a way you can do that actually. And how you can do that is with import static. And there are 2 ways to do it. This is one way to do it. I'm honestly not a huge fan of it, because what happens is now you have a whole bunch of things that you're importing, and it can get a little confusing whether you're talking about the imported information or whether you're talking about local information. For those with a C++ background, this is the equivalent of using namespace and using it at the top level, and traditionally in that community it's a bit of a no-no. In the Java community, I wouldn't say it's as big of a no-no as it is in the C++ community, but still, I'd say most don't really like this syntax. Instead, what you want to do is you want to be explicit as far as what you're explicitly importing. So now it's telling me I'm not using this import statement, and that's because I'm still calling math dot. And there we go. So basically what I just did is I said, okay, every single time that you want to call pow, what you're really doing is you're calling java.lang.math.pow. So that is a simpler way in order to call the math library's pow function without having to precede it with math dot every time. And the reason that we have to do import static is because these are static methods, and this also works on static fields as well, and we have to access them that way. Just like when we use the import statement for anything with instances, it shortens the code to be able to say import, and then you can use the last element in the import statement as the beginning of the type that you're using. Import static is the same concept. So one thing that I did skirt around a little bit that I want to address is when I gave this example, I didn't use the static demo class. And that was very intentional. The reason is because whenever you use the import keyword, you need to import from a package. And main and static demo are what we call being in the default package, which actually is not a very good Java practice other than for something like a tutorial where you're just talking about general use cases of files and classes and things like that. Normally what you'd want to do is you'd want to create a package and then you put your classes into a package. So what you can't do is you can't import anything from the default package. So if I were to attempt to do import of static demo, if I hover over this, it says class static demo is in the default package. Basically, if you were to look up the Java language specification, it says there's a compile time error if you attempt to import from the default package. So that's a no-no. So anyway, if you're trying to play around with the import keyword and the import static keyword and you're not sure what's going on, that might be what's going on. All right, so now that we've covered methods, let's go ahead and talk about fields. While we are using the math class, I'll talk about how within the math class, you have fields, so this little F right here, so pi. So if I were to look at the math class's source code, there is going to be a static field, and you can access it similar to how you would access a method. So instead of taking 5 to the third power, let's take it to the pi power. Run this code. All right, and as expected, the number is greater than 5 to the third of 125 and less than 5 to the fourth, which is 625. So that looks pretty accurate to me. Just like how I can use import static to import methods, I can also use import static to import fields. Now, you'll see that the output didn't change. And syntax is pretty clear of what we're doing. We're using pow, and we're using pi. One thing I want to talk about with import static really quick is you got to make sure that you use it in a way that makes sense, because a lot of time if you abuse import static, then your code gets really hard to read because you're importing all these random static methods and fields from other classes, and people then have to look at your import statements while they're looking at your code. And in this case, it's not too bad because we're talking about line 5 versus lines 1 and 2. But when you have a Java class that's 5,000 lines long, which, by the way, you should be asking why it's 5,000 lines long. But let's say you do have that, then you're looking at line 3,782 and you're wondering what in the world is this static method or field? I don't see this in here. And then turns out it's getting imported randomly from some other class. And even better, you don't even know which class because you have a whole bunch of wildcard, those asterisk imports. So now you got to look elsewhere in the code to figure out which method you're actually importing from. Okay, so a little more on fields. So just like how we have a static method here, let's go ahead and create a static field. Let's go ahead and make it an integer. And let's make it public so we can access it. So now if I wanted to access the myInt field from within static demo, I would do static demo.myInt. Now I want to print it out. And I'll go ahead and just comment these out here for a second. All right, cool. So the important thing to know about static fields is that when you are making various instances of a class, so let's say that I made 1,000 static demo instances, internal to the Java virtual machine while it's running your code, it's only going to create one of your myInt variables here. And that's because it's static and it belongs to the class. So for every time that you have a class static demo hanging around, which many times would be just one, then what you're going to do is you're only going to have one reference to all of the static members and fields of that particular class. Whereas when you have instances of your classes, you're going to have n number of instances of each of the instance fields, instance methods, so on and so forth. So that's an important distinction to understand. Another important thing to know is if you come from a C or C++ background, you can have static locals. So let's say that I want to declare a static variable within a function, and then I want it to stick around so that next time that I enter that function, I can then do something with it and I can maintain some sort of local state. Java doesn't support anything like that. The highest level of variable level assignment of static is going to be with a field. So at a class level, you can use static fields, but you can't use static locals within a method. All right, you guys still with me? So we have gone through 3 out of the 5 things we want to talk about. We've talked about import static, we've talked about static methods, and we've talked about static fields. The next thing we're going to talk about is static initializers, and the last thing we're going to talk about is static nested classes. So let's go to static initializers next. So one thing we haven't talked about very much is there are also things called instance initializers, and that's exactly what this is right here. That's out of the scope of the current video, and maybe I can cover that in the future. So what we're going to do here is we're going to add the static keyword, and now we have a static initializer. So what this means is whenever your class gets loaded within your program, what happens is the static initializer gets executed. Just like how you now have access to your static fields and your static methods, your static initializer is now going to get executed. You might be thinking, what's the point of this? Well, let me show you. Let's say that I've got a public static int result, and I've got a myInt, and then I've got another int. So what I can do here is I can say temp equals myInt times another int. And oh, whoops, this is actually something I should talk about. So what I'm doing here is I'm doing illegal syntax because it's saying that I have a forward reference. This is not something you see in Java super often. What it comes down to is the order in which you initialize static fields and static methods within your Java class matters. So really, all I have to do if I want to use my int and another int within this static initializer is I need to define them before my initializer. And now the error goes away. So anyway, back to the example. Let's say that now I need to do some conditional logic. If temp is greater than 10, then result is going to equal 2. Let's actually make this a Boolean, make it a little more realistic. Then we'll say result equals true, else result equals false. So what a static initializer allows you to do is if you have some code that you need to process when it comes to static context at the time of loading your class, you can do that within here. Now, if I change this code around, my result field can be updated and I can have a guarantee that by the time I create an instance, my result field has a known value rather than me needing to remember to set this every time that I have a constructor, for example. Static initializers, you don't see them super often within code, but they are very useful and they do have their place within programming within Java. All right, so now the last thing we're going to talk about is static nested classes. I'm going to go ahead and clean this up. I'll even clean this up here too. And we haven't talked about nested classes very much, and the reason for that is because there are 2 main types of nested classes. There are static nested classes, and then there are instance nested classes, which are just called inner classes. So I'm not going to talk about inner classes in this video, I'm just going to talk about static nested classes. So how do I do that? Well, if I want to create a nested class, I define a class within a class. public static class inner class. Nope, don't need the parentheses. Okay, so I'm not doing anything with my inner class right now. So now let's say I want to access inner class from main. The way that I do that is I do static demo.inner class. Inner class equals new static demo.inner class. So what I'm doing here is I'm creating an instance of a static class. Is that a little confusing? Now I'm mixing instances and static again. Well, really what the static keyword means within classes is that the class that is the parent of the static nested class, there's no relationship here when it comes to instances. So basically, if I want to create this inner class here, I don't need an instance of static demo in order to do that. The main reason that I would have something like this is, let's say that I have this really complicated class and then I want to compartmentalize some functionality into these smaller classes, but they want to be related to the top level class. So math doesn't do it, that I know of at least, but let's say that we were to grab the JDK's math class, and let's say they wanted to have a whole bunch of static methods related to trigonometry, some related to algebra, and some related to calculus. So how they could have implemented it is they could have said public class math, and they could have had public static class trigonometry, public static class algebra, public static class calculus. And then that way you don't have to create an instance of math in order to create instances of your static classes. Now, probably one of the reasons that they didn't do that is because within the static class of math, everything is static already in there. So at that rate, you don't really need a static class to accomplish further compartmentalization of your static methods. At least I don't think that's necessarily great practice all the time. But where it is useful is if you need to create instances of your inner class, you need to do something with your instance. Now you have a way to segregate between what your parent class is doing and what the nested class is doing. And I need to be careful. When I'm talking about parent class, I'm not talking about inheritance relationship, because there's no inheritance going on here. All of this is a nested class. There's actually no direct relation other than the scoping of how I access the inner class. And in fact, let's say that I didn't want anybody else to know about this inner class. I could mark it private. And now I don't know what inner class is within my main class. And what I can do is I can now do some particular processing within my inner class for my static demo class. This is something you might see a little more often, or maybe even a little more often, is you would see this. And this is where now you have the static demo, this, and super references within inner class if you wanted them, because as soon as you add the static keyword, just like how with static methods, you don't have access to this and super of the class that owns the static method, the same concept is here. When you add static, you no longer have access to this and super of the class that is owning the static nested class. And that is the static keyword within Java. I talked about 5 different use cases for the static keyword, times that you would use it, times that you wouldn't, some good and bad practices of using it. Hopefully you found this video helpful, and I'll continue to make videos on different keywords and different concepts within Java. If you like this video, please do smash that like button. Drop a comment below if you had any thoughts that you wanted to share. I love to see your guys' comments. Thanks again for watching this video. I hope you have a good rest of your day, and I hope to see you next time. Take care.